Hello friends, welcome to engineering tutorial. So we'll continue our discussion with the subject of engineering thermodynamics, and so far we have discussed various things related to the basic introductory things related to engineering thermodynamics, starting from the basic introductory concepts about the macroscopic and microscopic approach, classical and statistical point of view, and then about thermodynamic process, state of a system, cycle, pure substance. So, and also about the different types of thermodynamic process. So in this video we are going to discuss about another important concept, which is basically related to the the macroscopic and microscopic point of view. So this topic is very much related to that concept. So it is the concept of continuum. So we know that thermodynamics is basically the study of energy transfer between system and surroundings. Okay, so three things come into play here: system, surroundings and boundary. Three things are very much important to define the system, the surroundings, the boundary, and then the energy transfer between them. Also, it studies the effect of energy transfer on the properties of the substance. Basically, the properties, the thermodynamic properties which come into play are pressure, volume and temperature. So here we already have discussed about this, but as this topic is related to this concept, so again we have to bring it into picture. So the macroscopic and microscopic point of view of thermodynamics. So the whole study of thermodynamics can be divided into these two categories. So in macroscopic approach, when we study a system, it can be anything, okay, starting from a small an object, whatever, the human body, a plant, a machine, anything we want to study, it is studied as a whole, okay, from what we can perceive, what we can see, without going into detail about the atomic and molecular events that are going on at the subatomic level. Okay, so in the macroscopic approach, a system is studied as a whole from what we can look, from what we can feel or perceive. The atomic and molecular events are neglected. Yes, but here an important thing is that the atomic and molecular events, they have a role in contributing to the change of the properties or affecting change on these properties. So it is the sum total of the individual atomic and molecular events, but they are not studied in specific. Okay, so the macroscopic approach which we are having this discussion, it is about the macroscopic approach to thermodynamics, which is called as the classical thermodynamics. Okay, in the microscopic approach, when we study a system, we consider it to be consisting of a large number of atoms, molecules, and it is studied from the point of view of the behavior of those atoms and molecules and their contribution, individual contribution in the affecting any change in property of the system. So each atom and molecule has a specific position, velocity, energy, momentum, whatever, and with time it changes, and those parameters, they contribute to change in the properties of the system. In the macroscopic approach, only their result, they are summed together, the effects of the individual atoms and molecules, they are summed together and the final result is studied. The individual molecular atomic behavior is not studied in macroscopic. In microscopic approach, the individual atomic behavior is studied. So there is rapid molecular or atomic movement in any system, and there are collisions between them, and because of these collisions there is change in the property of the system. So the microscopic approach to thermodynamics is called as statistical thermodynamics. So where does this concept of continuum come into play? So the concept of continuum actually brings together the macroscopic and the microscopic approach, okay, where the system is studied as a whole in macroscopic approach, whereas in microscopic approach we take a certain section of it and study the individual molecular behavior. Okay, so the concept of continuum brings together these two approaches, this classical and statistical view of thermodynamics. Now, as we know that matter is made up of many atoms and molecules which are tightly packed, okay, the interatomic distance is different for solid, liquids and gases, but no matter in case of solids also, even though they are tightly packed, there are empty spaces between them. In the macroscopic approach, we assume that the mass distribution is uniform, that the same amount of mass is present per unit volume everywhere. But in actual, it is not like that. Okay, and as a result of which, the properties which we assume that they are constant everywhere, it is not like that. So the concept of continuum tries to, it assumes a continuous or uniform distribution of whatever property we are studying, which we assume as constant everywhere, but actually it is not. So let us take the example of density of a substance. Let us consider a small mass, let's say delta m, and a small volume delta v. Okay, we consider a system consisting of a substance, and we considered a small mass, very small amount of mass delta m, and a very small amount of volume or space delta v, and the mass enclosed within that volume. Okay, so if we try to calculate the density here, the average mass density of this system in the small volume is delta m by delta v. Now let us say the density of this substance is rho. Okay, so delta m by delta v should also be rho, isn't it? The density is constant for the system, whatever, no matter anywhere we take the sample, it will have the same density. So the concept of continuum assumes that delta m by delta v is rho. But when we go into the detail, we minimize the volume, when we keep on decreasing this sample volume, this sample space delta v, when we keep on decreasing it, we will find that this delta m by delta v for very small values of delta v, it will not be equal to rho. Okay, the density will not be equal to rho, it will be slightly different. Now why this happens? Because when we keep on decreasing the space, the sample space from which we are taking the sample for study, when we decrease the value of delta v, when we keep on decreasing the volume, because of rapid molecular movement, okay, molecules moving in and out of the system, collision, because of that, the density m by v, delta m by delta v, it will fluctuate because molecules are rapidly moving in and out of the system. So mass will keep on changing. It is not uniform for that small volume. When we take the whole system when we take the system as a whole, yes, the molecular movement does not affect that much. But when we take a small volume, okay, when we take a very small volume and we keep on decreasing it, molecules will be rapidly moving in and out of that small volume. So that will affect the mass m, the mass delta m, and that will bring about a change in the volume. So the concept of continuum it tries to find out the minimum value of delta V for which delta M by delta V is equal to rho. Okay, it tries to find the minimum value of delta V for which delta M by delta V will be equal to rho. Now density will be equal to the density of the substance which we assume. So here we have taken the example of density. You can take any other example also. So here this is the plot we can see. This is delta V, the small amount of volume of the sample space, and this is the delta M by delta V average mass density. So when the volume is decreased and taken to a point delta V subscript O, up to this point the density is being fixed, rho. But when it is minimized or it is decreased beyond delta V0, beyond this point, critical point, there is fluctuation in the average mass density value because of molecular effects. So this region is affected by molecular movement, and this is the region of continuum, where the property is still remaining constant. It is the mass distribution is uniform and the property remaining constant. But beyond this point, when the volume is decreased further, the property is no longer constant, it fluctuates because of molecular effect. So this is the domain of molecular behavior, it is affected by molecular behavior, and this is the domain of continuum where the property is remaining constant. So you got the point here. When we try to decrease the volume here going into the subatomic level where the molecular effects come into play, the properties which we previously assumed to be constant for a system, they even start fluctuating where the molecular effects come into play. So this is the plot. We can divide it into two parts, the continuum zone and this is the molecular effect zone. Okay, so this is the example which we took for studying the concept of continuum in terms of mass density of a system. Okay, so we can define density as limit delta V tends to delta V0, which is the limiting value, the critical value, the minimum value of delta V for which the density is equal to rho, as limit delta V tends to delta V subscript O delta M by delta V. When the value is decreased below delta V0, it is no longer constant and fluctuates because of molecular effects. Okay, so this is the concept of continuum. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.